Hello, scholars. This is Mr. Lowe. As promised, this is the video recording for the last part of writing equations of lines. So these equations of lines are for parallel and perpendicular lines. So to start off, we have to review the concept of parallel and perpendicular lines as it relates to its slope. So if you have parallel lines, remember the slopes have to be the same. The slopes of both lines have to be the same. So notice that in the diagram, the first line has a slope of 1/2. The second line has a slope of 1/2. So they have to be the same. For perpendicular lines, the slopes have to be opposites of each other, and they must be reciprocals of each other. So remember, that was taught in section 2.2 on slope. So notice that you have one slope that is -2/3, and you have one slope that is 3/2. So opposite means one positive, one negative. Reciprocal means one of the numbers is the flipped over version of the other. So 2/3, if you flip it over, is 3/2. So opposite and reciprocal. So when we are writing the equation of a line, there are three things that are going to be given to you. So three things will be given to you. The first thing will be a point. So you will be given a point. Second, you will be told whether you want parallel or perpendicular. And then lastly, you'll be given an equation. Y equals something or something in standard form that you would have to rewrite. So each of these parts serve a purpose for the solving of your problem. So to highlight this, we're going to look at example 5, both A and B. So for 5A, we're being asked to write the equation of a line that passes through 8, -3. So there's the point that I was talking about. And is parallel, remember they will tell you parallel or perpendicular, to the line y equals 3/2x minus 1. So those are the three parts that I had mentioned earlier. So we kick things off with y equals 3/2x minus 1. The equation that they give you, you need to first get the slope from it. So this is already in slope-intercept form, so that's 3/2. Once you get the slope, now we use the parallel or perpendicular aspect. Remember, parallel slopes have to be the same. So that means if the first slope was 3/2, the parallel slope has to be 3/2. So we use the equation to identify the slope and to get the parallel slope in this case. We'll do another example for perpendicular. Once we have the parallel slope, then we no longer need the equation. We no longer need the slope that we had to start, and we no longer need to know parallel. We have everything that we need. We have everything that we need to solve this problem. So now to finish the problem, we use the parallel slope, which was 3/2, and the point, which was 8, -3. So you got a slope and you got a point, so that's point slope form all day. We substitute everything. That's y minus -3 equals 3/2 x minus 8. And now we're just doing the algebra associated with simplifying. Two negatives gives you a positive, so y plus 3 equals 3/2 times x is 3/2x. 3/2 times 8. So 3/2 times 8, 3 times 8 is 24. 24 divided by 2 leaves you with 12. So to get y by itself, subtract 3 on both sides. So y equals 3 over 2x minus 15. So that is the equation of the parallel line for y equals 3 over 2x minus 1. So if you were to graph the original equation and the parallel line, they would indeed be parallel. They would indeed be parallel. So we use the equation that they gave us to identify the slope and to get the parallel slope. Once we do that, we use the parallel slope and the point to write the equation. So one flows into the other. So that's for parallel lines. Now, for part B, we're still using the same point. So let me bring some stuff down here. We're still using the same point, so 8 comma negative 3. But now we want a perpendicular line to 4x plus 3y equals 15. So now we want a perpendicular line. So again, we first start with the equation that was provided to us. 4x plus 3y equals 15. Now, a little bit trickier in this case because this is not in slope-intercept form. We need the slope. So we need to transform this equation into y equals something so that we can get slope-intercept form. Subtract 4x on both sides. So 3y equals negative 4x plus 15. Divide everything by 3. So you get y equals negative 4 over 3x plus 5. Now that it's rewritten into slope-intercept form, your slope is negative 4 over 3. So the slope is negative 4 over 3. But keep in mind, we want perpendicular. You want the perpendicular slope. So perpendicular means opposite and reciprocal. So your perpendicular slope, opposite means instead of negative, it's going to be positive. Reciprocal means we take the fraction and we flip it over. So 3 over 4. So your perpendicular slope is 3 over 4. Now that we have the perpendicular slope, remember, once we get the perpendicular slope, we do not need anything associated with the original equation. So all of this, we don't need anymore. Don't need that anymore, and we don't need perpendicular anymore. All we need is the perpendicular slope and the point that it needs to pass through. These are the only two parts of the problem that we need for the rest of the problem. So now we can go ahead and solve. We have a slope and we have a point. So we go back to the point slope formula. So y minus negative 3 equals 3 over 4, parentheses x minus 8. Again, two negatives next to each other would turn to a positive. 3 over 4 times x is 3 over 4. 3 over 4 times 8. 3 times 8 is 24. 24 divided by 4 is 6. And then subtract 3 on both sides. So y equals 3 over 4x minus 9. So that is your perpendicular equation. So just as I mentioned with parallel, if we were to graph the original line and graph the perpendicular line, you would see that they would meet to form a right angle. You would see that point in which they would meet to form a right angle. So again, that's how we work parallel and perpendicular. Parallel, remember the slopes have to match original equation to new equation. perpendicular, the slopes have to be opposites and reciprocal from original equation to new equation. That's essentially how you solve out the problem. So in the notes handout that will be uploaded to Google Classroom, you'll have these two examples along with examples 6 and 7. So again, remember, you'll be told, given a point, parallel or perpendicular, and then an equation. A point, parallel or perpendicular, and an equation. So you are given the original equation. You need to figure out what the new equation is going to be. And that's what happens with both of them. So that will be uploaded to Google Classroom, but this now completes the additional instruction needed for section 2.4. This video will be uploaded along with a general overview of all of the types that we went through. If you have questions, please feel free to let me know. Otherwise, take care, and I'll talk to you soon.